file formats. Now we look into image acquisition. So also known as digital imaging. A method for creating a digital images involved with 3 steps. When we want to take picture, they are the energy, optical system, and also sensors. This is the processes in acquiring image. So energy in this case is light or electromagnetic wave. Okay, kena when you want to take picture, you need light. And when this is light, it relationship with electromagnetic wave. So light is the pure energy, you need light, and electromagnetic wave. So energy carrying waves emitted by vibrating electrons. So just think, I mean usually ambil gambar, you just snap and the picture appear in your screen, in your memory semua kan. But this is the first step. You need, there are these 2 energies required, light and also the electromagnetic waves. Okay, so models of light. So you have, this is your image, this is your electrical energy, and this magnetic energy. So energy determines the penetration depth, and given by this equation, H equal to Planck, E, the energy equal to H, V, Planck constant, and V is the frequency. So there are many factors, there are many effects when you want to capture an image. Okay, but this is the basic one based on this equation. Okay, and it's and we know that the electromagnetic radiation travels as a wave, and wavelength determines the size of the object that can be detected and the speed of light. So this is given by this equation. Lambda, the wavelength, equal to speed of light over frequency. And speed of light is a constant, 3 times the power 10 power of 8 millisecond, very fast. So this is about the electromagnetic. Okay, so as we can see, how the energy and wavelength work relate to each other. So increasing wavelength, that means decrease the energy. They work oppositely. Okay. So and then this wavelength, we have different categories. Okay, different categories based on the wavelength, from very small 0.001 nanometer to 100 meter. Okay, so this one, this is the energy, ada radio wave, infrared, ultraviolet, X-ray ataupun gamma rays. Okay, so the visible light between this area, that the one that we can see, we cannot really see the X-rays. This is like, you know, the X-ray machine. You have to use special display, special sensors to see this X-ray between this wavelength. So this area only between here, this is 10 nanometer, this is 1000 nanometer, this is the visible light. So this is for electromagnetic spectrum. Okay, do you agree that the spectrum does not contain all the colors that the human eyes and brain can distinguish? Justify your answer. Kan? Ada daripada from this one, there are areas that we cannot see. Radio waves also we cannot see. Okay, colors that the human eyes and brain can distinguish. Justify your answer. Okay. So this is, I mean, I'm too tired to let you think. So I just explain. Okay. Visible light spectrum, we can only see the basic color, red, orange, yellow, green, blue, violet. And these colors are called pure spectral color. And what is spectral color? Spectral color is evoked by single wavelength of light in the visible spectrum. Go back to the previous slide, ada visible spectrum tu. And you can see that it's a just narrow band of length, also known as this monochromatic light lah. And the spectrum is continuous, dia tak ada clear boundaries from between one color and the next. So that's why that's why we can see. And there are other unsaturated colors such as pink, purple, magenta. They are mix of multiple wavelengths. So this one yang kita boleh tengok, yang included in the visible light spectrum. This color they are mixed. Okay, the multi-wavelength sun. So kita ada X-ray, ultraviolet. So this is visible, composite, radio, infrared. So we can use visible, yang ni kita boleh nampak. Yang lain-lain tu you can see but using a special machine, not included, not indeed in that visible spectrum. So the spectrum just now ada I mentioned ada radio waves. This is all electromagnetic. Ada yang boleh nampak, ada electromagnetic wave tu yang tak boleh nampak, like radio waves used for communication, microwave used to cook, infrared, heat wave, visible light. So the electromagnetic signal, the electromagnetic wave yang kita boleh nampak very small range, that is visible light that can be detected by our eyes. Ultraviolet, we cannot see that, but you can see the effect. You dapat sunburn. X-rays can penetrate tissues. So kalau you tahu the most common application when your sisters or mothers pregnant, you do pergi buat ultrasound check. So that one, that electromagnetic wave called X-rays, they can penetrate tissues and you can see what's inside. You can see in the womb tu kan. And the gamma rays is the most energetic because it's very small. This is the most energetic wave. So, okay. So we have this one, how the image formation. We need your energy, your light source, illumination source, scene element, and you have the system here. Okay, dalam ni ada like film or whatever, how you store it. So this is how we capture the form the image using the acquisition system. Okay, illumination. So this one explained from this one, from this image, illumination. Energy source to illuminate the scene. And of this, they're affected by the direction of the light source that cause the image to be too bright or dark or non-uniform illumination. And backlighting is also important, illumination that highlight the outline of an object. So this one, kalau in a room, indoor should be no problem, but if you are pergi beach, you can see that the effect of backlight and everything. Okay. So this one, the effect of illuminating a face from 4 different directions. So when you take picture, you can see that how you adjust your position can affect your face too. Okay, and nowadays pun dia ada angle atas bawah, nak bagi efek kurus ke, nak bagi efek slim, muka kecil. So this one, that is the effect of illuminating a face, illuminating your position lah, and then you will get different output. So backlighting, the light source is behind the object of interest, will make the object stand out as black silhouette. Okay, so kalau you letak your source of light at the back, so you will get silhouette image. If you notice, kalau yang professional photo shoot, the light is not at the back but in front of the object. So this is what happens when you put the light behind your object. Optical system introduced to overcome the problem of creating useless image due to the rays of light from different points on the object, hit multiple points on the sensor, and in some cases even the same point. So we use lens. So nowadays memang ada lens that you can address those issues lah with the light and everything. Okay. So this one just to show about the itulah with small holes, really reduce the noise problem. So we have object. we have sensors here. Before introducing a barrier, the rays of light, so sini, okay, the rays of light from different point on the tree hit multiple points of the sensor, and in some cases in some points. So dia akan banyak point. So we put something barrier. So barriers ni less lah dia control ada shutter ke, ada speed. So we control how the light tu, the object hit the sensor. Could reduce this problem. Daripada banyak-banyak point kena kat sensor, now with this barrier, just we can focus to minimize the problem. Okay, so this is the first camera. Dia terbalik. Okay, I think we learn this in physics kan. Terbalik is a black box, dia ada small hole. Okay. But the issue, dia ada small hole ataupun called pinhole. Okay, pinhole size. Now if you are into photography, when you learn about picture photo taking semua, there are one term you can control called the aperture, the bukaan kamera tu. When they capture the image, the aperture control tu can for sharpness of the image tu, the control of the size of the picture, ataupun nama dia pinhole size. And pinhole size must be very small to obtain a clear image. But the issue is bila too small, when the aperture is too small, that means you will get very little light. Less light is received by the image plane. So dia akan ada trade-off lah kat situ. So if pinhole is comparable to wavelength of incoming light, it will cause the image to be blur. So this picture here, we can see this pinhole camera, different size, the variation in the picture clarity too, as the hole diameter decreases. So ni 2 mm, ni 1 mm, ni 0.6, ni 0.35, ni 0.15, ni 0.07. So, but there is an equation to control this given by this equation. And they have controlled by this, apa namanya, effective focal length. So, dia ada effect by the, ni lah, amount of light. So, that's why, yes, it's true. The smaller the aperture, you will get clear image, but there is a trade-off bilangan cahaya yang masuk. So when we use lens, why we need lens? Lenses are used to avoid problem with pinholes. For ideal lens, same projection as pinhole, tapi dia it can gather more light. So that's why we use lens. So this is barrier tadi kan. So with this lens, it will focuses light onto the film. So film or memory yang kita simpan the file lah. There is a specific distance at which objects are in focus. Other points project to a circle confusion in the image. Changing the shape of lens, changing this distance. You know that again, if you're into camera, dia ada banyak sangat jenis lens. Ada wide lens, ada I think I've read. So there are many types of lens. So that is how we want the aim to get a bit better picture, better quality of images. So this is apa ke namanya, terms that are what we have in lenses. Dia ada aperture, dia ada optical axis, and in the middle here dia ada center of projection, focal point, and this is the F. F tadi apa? Focal point tu lah. Daripada center of projection to the focal point. Okay. So I think apa yang kita nampak, what you visually see when we want to take picture, there is a green box. So green box, they will focus where the location of the green box will point out the focus of the picture. So how can we change the focus region? How can we change the focus region? Okay, so this is ada terms in image tu, we call it as DOF. Sometimes ada juga DOF ni degree of freedom, but for image, DOF is depth of field, also called focus range or effective focus range, and is the distance between the nearest and farthest object in the scene that appear acceptable sharp in an image. So this one, kalau you tengok semuanya blur. 3 different camera setting resulting in 3 different depth of field. Okay, dia ada tu lah, ada group discussion. Depth field is determined by 3 factors, aperture size, distance to subject, and focal length. So it explains in details how each one works. So I think this one kita stop sampai sini. I will ask in the next class, our class in 2 weeks, depth of field. So that means for our test, I will cover only sampai part 1. This is part 2. Sekarang ni yang I tunjuk ni part 2. So for this, for test, topic covers until image part 1. This one we'll discuss in 2 weeks time. So I will ask randomly. You can discuss in group, but during class nanti saya akan tanya, itulah akan tanya individually. Okay?
Okay, Doktor.
Okay, so I think that's all. I will start the recording.